Okay, hello everyone. Welcome back to our annual conference, annual meeting. We'll get started. So our next session is a panel session we're calling From Berkshires to the Bay, an overview of flood mitigation across the Commonwealth. We've got some great speakers here today, and also a great moderator for this discussion, and that is Bob Seay. For those of you who do not know, Bob Seay is a former morning edition host and is a continuing reporter for GBH News, and he'll take it from here. So I'll pass it off to you, Bob.
Well, thank you very much, Noah, for inviting me to host this fascinating panel. And behind me is my favorite floodplain, that's Coast Guard Beach in Eastham. But as I've learned exploring this topic, there's a lot more floodplains than along the coast. And we're going to be hearing that today, as the title indicates, from the Berkshires to the Bay. We're going to start in the Berkshires with Kimberly Noake MacPhee, who's Land Use and Natural Resources Planning Program Manager for the Franklin Regional Council of Governments based in Greenfield. Then we'll hear from Herbst, Senior Environmental Planner for the Metropolitan Area Planning Council. And then Mark Borrelli, Coastal Geologist for the Center for Coastal Studies in Provincetown. So welcome to you all and our participants today. We're going to open by having our guests each introduce themselves and also talk about some of the work that they're doing. So let's begin with Kimberly MacPhee out in Greenfield. Kimberly.
Thank you. Am I supposed to start the PowerPoint?
Yes, yeah.
Yes, okay, I'm sorry. So,
and if you want, I can pull it up and share it if that's easier for you.
no, I should be able to do it. I'm sorry. Oh my goodness. There we go. Can everyone see it?
No, you'll have to click screen share.
Okay. Just when you think you have this all figured out.
Okay, we're all still getting used to this.
What? Share. There we go. Okay, I'm sorry. Now. Yay, everyone can see that now.
Yeah, just so you know, Kimberly, we're seeing the presenter view, so we have both the big one and the small one.
If you go up to display settings up there, yeah,
Okay.
If you start from the beginning and then go to display settings up top, you should be able to switch the screens. Yeah, I've done this so many times. Up top it says, if you can see can you see the other slide? Our.
Oh my gosh, I don't know what's going on here. You were screen sharing, okay.
Oh, maybe unclick use presenter view right there.
I don't see, oh, I see it, okay. Good grief, all right.
There you go.
Perfect.
Thank you. I apologize to everyone for the glitches. I'm really happy to be here this afternoon to talk to you about the work that the Franklin Regional Council of Governments has been doing for about a decade in the Deerfield River watershed in Franklin County. So back in 2008, we had done a watershed-wide assessment that inventoried the conditions of the major tributaries to the Deerfield, and we were really struck by the fact that we were seeing widespread fluvial erosion, a lot of threats to infrastructure, and we had questions about, are these rivers really healthy, and are these rivers resilient to climate change? Because if you look at the water quality data, for example, or you look at the amount of habitat that we have in this watershed, it's really, it is a healthy watershed if you use those metrics. But we wanted to try to understand what was going on and kind of explain what we were seeing in these tributary watersheds. So we needed a science-based approach to help us frame the problem, understand the problem, and then using that science-based approach, come up with ideas and management strategies to reduce the conflicts between the river and the built environment and restore the river functions and the river system. So first we wanted to understand the problem, then we needed to identify restoration projects, and the third step was to identify management areas and strategies. And I really want to put a big shout out to the Vermont Rivers Program, which was an inspiration to the work that I've been doing, and also a source of a lot of great information to inform the work that the Franklin Regional Council of Governments has been doing. So the first step was to understand the problem. So what is the science we're going to use to understand the problem? And the science is fluvial geomorphology, which is the study of how rivers interact with the lands around them. And I love this quote from the US Geological Survey because it really just encapsulates what we've been doing. It's like, in order to develop effective management strategies, conservation strategies, and restoration strategies, you really need to understand how the river is interacting with its landscape, and also how the river is responding to stresses in its watershed, both historic, current, and future. So we started our work in the South River watershed, which is a major tributary to the Deerfield. And we piloted a model fluvial geomorphic and habitat assessment methodology in the South River. We identified 20 projects that are consistent with the principles of fluvial geomorphology. And if they are built, they would provide multiple benefits. They would abate the erosion, they would improve channel stability, alleviate flooding, and also improve habitat, which has been severely degraded in this watershed. So we took that model assessment methodology and piloted it in the North River watershed in 2014. So we've completed step 1 and 2. We have the science to help us understand the problem. We've identified restoration strategies and project locations. And the next step was to identify a management area and strategies for that management area. So the strategy is really avoidance, right? We want to think of ways that we can direct future development away from the hazard areas. And if new development or redevelopment projects are happening in these hazard areas, what are some tools that we can use to help mitigate the flooding and the fluvial erosion hazards? So the river corridor was our management area. The river corridor includes the active area of the channel and the portion of the riparian lands where the river wants to do what rivers do, which it wants to erode its banks, it wants to deposit sediment and dissipate flood flows. You can see in this image on the right that a river corridor is very different from management corridors that we're used to working with here in Massachusetts. The 200-foot riverfront area is a management corridor, a resource area that is delineated under the Wetlands Protection Act. And that's like a setback or like a buffer area. Whereas a river corridor is going to change in width as it goes along the course of a river. The other management area, of course, that we're all familiar with is the 100-year floodplain. This is a map of downtown Conway, and I've got a graphic that shows the difference between the mapped river corridor and the FEMA regulated 100-year floodplain. So you can see here the river corridor area is the darker blue area, and the 100-year floodplain is the lighter area. And there's a lot of infrastructure in these hazard areas. So again, the river corridor identifies not only the inundation hazards like the rising bathtub flooding hazard areas, but also areas of fluvial erosion hazards. So we developed a mapping protocol, which I can talk more about later in the question and answer session, but we piloted this mapping protocol in 2 of the larger watersheds in the Deerfield. So what's in our toolkit for climate resilient rivers? We have assessment and restoration tools. So we have the fluvial geomorphic and habitat assessment methodology that I talked about, and the application of that in the North River watershed and the South River watershed. We now have over 40 river restoration projects in our toolkit. So if I had unlimited money and unlimited time, I could get those projects done. Something kind of more practical and somewhat easier to implement are these avoidance strategy management tools. So using the mapped river corridor that we have now in Franklin County, we've got one in, again, the North River, the Green River, and the South River. We can work with the communities in those watersheds to think about adopting a model river corridor protection overlay district or a river corridor easement. And these are two great tools that I can talk about again in more detail later. But these tools are brand new, kind of new to Massachusetts river protection tools. So I'm pretty excited about them. Last thing, just kind of as a jumping off point or things to think about, the list of barriers and opportunities that have come up over the years. I think one significant barrier is the high cost of the environmental permitting that's associated with these river restoration projects. And to date, we've only been able to build 2 out of the 40. The last one that is actually just wrapping up on the North River took almost 5 years to wend its way through the environmental permitting process. And part of that is because the regulatory agencies, this is a new approach in Massachusetts. And so, you know, understandably so, there are a lot of questions, and especially in an area like the Deerfield River watershed where we have cold water fisheries resources and all this wonderful habitat, you know, we have to make sure that the work that we're doing is going to be an improvement. So one thing that might help streamline this permitting process is you have like pre-approved designs that already, you know, have been vetted by the state regulatory agencies. So if you're doing a floodplain reconnection project, you're doing a bank stabilization project, you're kind of already like many steps ahead in the process if you're using these pre-approved designs. We have a lot of land in private ownership, so that's a potential barrier. However, these 2 tools, the corridor easement and the overlay district, which I put in italics because any zoning can be, you know, new zoning controls can be met with skepticism. Funding for implementation, there is a lot of money available, but there are always match requirements, which are hard for our smaller communities to meet sometime. I have been and continue to look for other ways to leverage this work, and there are a lot of opportunities to leverage this river work and this climate resiliency work with other initiatives that are happening. And we're hoping that people will take the toolkit that we've developed and piloted in the Deerfield River watershed and think about how it can be adapted and used in other watersheds and other, you know, geologic and fluvial geomorphic settings across the state. So that was my condensing of 10 plus years of work in hopefully 5 minutes.
Excellent job, Kimberly. Did very well. Fascinating. So we've just learned about rivers in Western Massachusetts. We're going to move eastward now to Ann Herbst, the Senior Environmental Planner at the Metropolitan Area Planning Council. which covers the greater Boston area. So, and from your perspective, what has your experience been in dealing with flood hazard? Okay, and I think you have to unmute yourself.
Oh, I've been chatting away.
There we go.
So I've been focusing on inland flooding, and I'll talk about a project we're working on. That I've been working on at MAPC to better understand inland flooding. So in March 2010, Eastern Massachusetts had a series of rainstorms that led to a federal disaster declaration. The declaration made assistance available to property owners who did not have flood insurance. And because the assistance was available to people without flood insurance, the data provides a much more comprehensive picture of where flooding occurred. But due to federal privacy requirements, it took us nearly 2 years to gain access to the data. And actually only the intervention of Joy Dupereau at DCR and Thad Legumores at MEMA made possible an agreement between MAPC and FEMA to obtain the data, and use of the data is still quite restricted. But a key take-home message from our analysis is that FEMA flood insurance rate maps captured only a small fraction of the flood damage locations. So this is the rain data from the Blue Hill Observatory, and we experienced a succession of 3 storms in March 2010. It was the rainiest month on record at the observatory dating back to 1891. And as you can see, the flood damage was significant. And this is what the claims map looks like for our MAPC region. And essentially the density of the claims pretty much mirrors the rainfall intensity map. So what we found was that over 90% of the claims were located outside of the special flood hazard area. And that's true even for flood insurance claims. Almost 40% were outside of the SHFA. And the disaster claims dwarfed the number of flood insurance claims by 20 to 1. And then when we looked only at our inland communities, we found that 97% of claims, again, were outside the special flood hazard area. So this is a bit of a close-up look at the town of Weymouth. There were only 3 communities in our region that had more claims than Weymouth. So the left panel shows the 1% floodplain in green, the 0.2% floodplain in orange, and streams in blue and wetlands in pink that are outside of that map floodplain. And then the black dots are structures. So perhaps the good news, if you look at this, is that there are actually very few structures in floodplain or wetlands. But the bad news is that a lot of flooding took place outside of those locations. And this is pretty typical across our towns, from the very urban to the more rural. So then the right graphic shows the relationship of the claims to the floodplains and wetlands. The purple dots are the claims. And you can see that a lot of the claims are relatively close to the identified wetland areas or floodplain, but really many have no apparent source of flooding. So, you know, the question to us was, why did the FEMA flood maps fail to capture the bulk of the claims? And I think that has a lot to do with what FEMA flood mapping is about. So the FEMA maps in inland areas identify flooding associated with waterways, so rivers, larger streams, ponds. And they don't capture all waterways because they don't customarily map drainage areas of less than a square mile. So, and as we all know, inland flooding can have many other causes. So that can include impervious surfaces, inadequate or failing stormwater infrastructure, also a variety of topographic and soils conditions, as well as high groundwater. Analysis we did for the town of Wayland showed that higher than the townwide average rate of flooding occurred for properties in the 1% and 0.2% flood zones, but that was also the case for properties within 100 feet of map wetlands, within 200 feet of surface water, over shallow bedrock, and within surface depressions. In many locations, we found actually quite remarkable correlation between historic wetlands and flood claims. So this is an example from Mattapan in Boston. And on the left is a USGS map from 1893 showing wetlands that existed at the time. And I hand drew in the location of the streams on the graphic to the right, and you can see the relationship of the streams and the former wetlands to the claims. Today's only remaining map wetlands in Mattapan are circled in red. So this, yeah, I think just really highlights the degree to which you can fill or bury wetlands, but they don't really go away. They continue to impact us. And then MAPC helps many communities develop their hazard mitigation plans. And as part of the process, we work with very knowledgeable town officials who identify local flooding hotspots. But as we've used the data, we've learned that for the most part, town staff didn't identify locations that flooded in 2010. So in this example, the town of Norwell identified several locations that did flood in 2010, but not the largest concentration where you see those pink dots. And I think we're finding, and we believe that in many cases, this flooding the damage is caused by basement flooding. So it's not as visible as a flooding roadway or river over its bank. But of course, it's still quite damaging to those who experience it. So to a large extent, municipalities and individuals rely on FEMA flood maps to identify where they should be concerned with flooding. But I think this data really raises a red flag that residents and town officials aren't warned or prepared for the likely extent of flooding in large storms. So some of the things we're thinking about related to this include how to improve mapping, getting access to claims data and what it means that we don't have it currently, how to communicate the risk, and thinking about regulating areas outside of the special flood hazard area. We also need to think about who's most at risk and how to address that. And we need to think about what this means for our capacity to identify future flood areas associated with climate projections for increased rain events. So I'll look forward to talking about some of those things when we get into the discussion. Thanks.
Thank you very much, Anne. And we turn now to our final participant on the panel, Mark Borrelli, coastal geologist for the Center for Coastal Studies in Provincetown. And although he physically is just a few miles from me, he looks a lot farther away than that. So Mark, go right ahead. Tell us about the work you're doing.
Sure. Can everybody see my screen here?
Yep.
Okay, so I'm turn off my video just for bandwidth, just in case. So what we're doing, I'm just gonna talk today. I'm a coastal geologist. I work at the Center for Coastal Studies and I'm research faculty at UMass Boston. And I'm gonna talk about a tool that we're working on over the last 4 or 5 years, really. What we're doing is we're mapping storm tide pathways. And basically, when we talk about this, we're talking about, we get a lot of questions about mapping versus modeling. What kind of modeling do you do? And what we do is we just do the mapping, and we'll talk about it a little bit. And we really think that both of these are important, right? Mapping and modeling. So my lab does the mapping of the storm tide pathways that we're talking about. And since 2017, we've been working with the National Weather Service, incorporating their real-time modeling of flooding and inundation, coastal flooding and inundation into our storm tide pathways maps. And when we started this, we wanted this tool to be useful and usable, and that's not always the case when you're doing this kind of work. We wanted it to address current and future concerns, meaning storms that are ongoing right now in real time, but also future storms and as well as sea level rise. We wanted to make sure people could use this, towns could use this with little to no computing resources. A lot of the smaller towns, especially out in the Cape, don't have GIS expertise, things like that. And of course, the main goal is here is to increase resiliency in the town's autonomy. So we'll start with just real quick what we've done. The first 2 projects through CCM grants were done with the town of Provincetown and the town of Nantucket. Then we started to partner with the National Weather Service to the town of Truro. We're working with Shannon Holst and the Cape Cod Cooperative Extension and the National Weather Service to do all of Cape Cod Bay, and the dashed lines means these projects are still in progress. We finished a project to map these storm tide pathways in Scituate and Cohasset through the MVP program last year. And right now we just started 2 different projects with Cape Cod Commission and another project on Martha's Vineyard funded through the CZM Coastal Resiliency Grants. So we're doing work in different places. And basically I'll walk you through it. Starting off of Provincetown, I probably don't need to tell this group what LIDAR data are, right? These are really good bathymetric or topographic data that you collect that usually the Army Corps of Engineers, the USGS collects. And I'm the director of the seafloor mapping program at the center also. So we have this really nice data visualization software. So this is downtown Provincetown. And if we sort of look at the same sort of screenshot with the like a lot of the sea level rise views out there, surging seas, you'll notice a few things. And these are wonderful maps and wonderful data sets, but you can't zoom in that much, right? The zoom in here is grayed out. So this is as tight as we can zoom in. And now we're all using the same data, right? We're all using this really good elevation data that NOAA, the Army Corps of Engineers, and USGS collects. But what we wanted to do is we wanted to take it to the next step. So we use our data visualization software. We can superimpose an aerial photograph onto that LiDAR data. So now the aerial photograph is a 3-dimensional surface. And what we do is we use the software to slowly raise up the water here in downtown Provincetown. And the moment this area water reaches this area here, There's low-lying areas in the back, and the ocean water hasn't yet connected to those low-lying areas. We can draw a cross-section or a profile through this data set, through the LiDAR data set with our software. And then we can start to do this analysis wherein we look at all these locations where the moment that water gets to this location, which is what we call a storm type pathway, this area will flood. The moment the water gets to this location, this entire area will flood. So these are 2 storm type pathways that we identified in 2016. And what I'll do is I'll ask you to keep an eye on the flower pot. Unfortunately, this is video taken from January of 2018. This is the blizzard for the January 4th, 2018, and this is salt water flowing over those storm tide pathways into Provincetown. There's a lot of flooding throughout Massachusetts here. I'll show you another quick video. This is a little bit later. The flower pot is sort of getting pushed across the crosswalk. But this, I wanted to show this image just a little shakier, but when he pivots back to the harbor and it stops, you can see the salt water is actually above the base of the door, right? So this is a problem. So the data that we give the town, we look at all these different data points. So you have all this information. We go out and shoot each one of these points. We've done over 2,000 of these points throughout all the projects that we showed you earlier, and we shoot them with an RTK GPS unit, so we have really accurate information there. In this instance, we gave the town a tide staff, so when they can look right out the window and see where the actual water level is. So they don't need all the technology. They can just look at their tide staff and see where the water levels are and be prepared for it. And the last thing we'll talk about is us partnering with the National Weather Service. The National Weather Service has this wonderful real-time data set for a lot of different harbors throughout Massachusetts and southern New England. And we'll focus on the total water level here in Provincetown Harbor. And as you can see, these are the storm tide pathways. Using their viewer, the app that they developed with us, you can go in and look at all the different storm tide pathways for all the different elevations, not only including storms of record, which is about 15.5 feet, but 3 or 4 feet more, so towns can start thinking about sea level rise. And this is just that zoom in of that data set from downtown Provincetown with all the information. Then when you mouse over it, and the last thing I'll say with the remaining of my time is that we're developing an app ourselves at the center, so we can just add more data. It's tricky to do stuff with the federal government sometimes, so we wanted to make sure that when new data become available, we wanted to tweak things and do that. We have that app, and it's coming soon, probably the next month or so, to our center website. And that's all I wanted to say. Thank you very much.
Thank you very much, Mark. And
Sure.
When I think back to that March 2018 flooding, I keep remembering the minister of the Unitarian Church there reporting that when she discovered fish swimming in the basement of the church, she said the bad news is the basement's flooded. The good news is the fisheries apparently are coming back. So
Yep, that's right.
that was quite a day. I remember that, though.
Yep.
All right. Well, that was really a great introduction to all of what you're doing. And specifically now, we'd like to zero in on the issue of the different types of flood hazards that you deal with specifically. So why don't we begin with Kimberly out in the Berkshires?
Sure. Well, what we see, we really see 2 kinds of hazards. We see the flooding hazard, you know, kind of like the level of the bathtub is rising or the level of the river is rising, and then the water spills over into adjacent lands. We also see a lot of what are called fluvial erosion hazards. And really, in a lot of ways, those fluvial erosion hazards are even more damaging than the flooding hazards. And what I mean by a fluvial erosion hazard is when when the river actually erodes its banks or drops sediment, and the river can actually change its course or jump its banks. And especially in the Deerfield River watershed, where we have very steep terrain in a lot of the major tributary watersheds, we have kind of like this perfect storm of steep terrain. The rivers are already disconnected from their floodplains, and there's the development that we do have, which, you know, we're very rural out here, but the development that we do have is concentrated in the floodplain and the river corridors. So we don't have, like Anne was talking about, kind of a lot of this urban flooding, except for maybe in the city of Greenfield in certain areas, we might get urban flooding. So the two hazards we're dealing with the most are riverine flooding, flooding associated with the rivers, and the fluvial erosion hazards.
And Anne, what about farther east and some of the metropolitan areas? What specifically are the flood hazards?
Sure. Well, for MAPC, we really have both coastal flooding because we have a lot of shoreline from Duxbury up to Cape Ann. But the focus of what I talked about today really is about urban stormwater flooding, and that I think is presents some unique challenges in the sense that I was talking about it. It's really not captured by flood mapping, so it's very often related to the size of stormwater infrastructure. Much of that infrastructure is underground, so often when there's really severe flooding, it's something that failed that would not have been easy to predict because you can't see it. Sometimes it's around some really basic things like, did those catch basins get cleaned before the storm? Much harder to predict where it's going to happen. I think from this March 2010, part of what we're seeing is a tremendous amount of basement flooding, which can be really, it's maybe less noticeable to folks, but can be really damaging, particularly if people have utilities in the basement and they're out of their homes sometimes for weeks for that reason. So.
And Mark, out on the Outer Cape, it might seem obvious what the hazards are, but are they that obvious, or are there some hazards we're not thinking about?
No, I mean, the primary hazards are coastal storms and sea level rise. Some of the problems on the Outer Cape, though, are they are small towns. They don't have a lot of infrastructure. And then in the summer times, they're overwhelmed with the tourists, and you can have a town with 2,000 or 3,000 people year-round population, and it can swell to 25 or 30,000. So handling those people in a confined space like that with quite frankly, one evacuation route for a lot of the Cape, right? There's 2 bridges off the Cape. So dealing with this thing, were we ever to get a hurricane in the summertime, it would be unimaginable, the chaos and the confusion and things like that. So, but the nor'easters, the things that do that steady damage every year, year after year, towns are coming to grips with trying to figure out, and management entities, regional management entities are trying to come to grips with, it's always about allocation of resources and what do you want to do and how do you want to do it. Sea level rise is coming. We know sea level rise is coming, but the next storm could do a lot more damage than 10 or 15 years of the next, set of sea level rise scenarios. So it's always that balancing act that I think the other 2 speakers are talking about, is how best to allocate the resources and what path to take.
Well, I'd also, I understand that each of you has a new project using some the new best available data you have and tools. Why don't you each of you tell us about that? Kimberly?
Sure. So the 2 tools, the avoidance strategy or management tools that are new to Massachusetts are the River Corridor Protection Overlay District and the River Corridor Easement. So both of those are predicated on having a river corridor delineated, right? So you have to go through the first step of the assessment and the delineation work of the river corridor. And once you have that management area, a River Corridor Protection Overlay District is a zoning tool. So it would overlay the existing zoning districts in the town. And so all land within the river corridor would be subject to additional either review or controls. There might be exclusions. There might be certain types of development that are not allowed in the river corridor overlay district. The other tool is a river corridor easement. So the way we're working on that is that it could be a standalone like conservation easement tool that in exchange for management rights of the river corridor lands, the landowner would be compensated for the value of the land as well as receive additional compensation for the climate resiliency benefits that the easement provides. So let's say it's flood resiliency in particular, for example. We're still working on the river corridor easement tool, and we have a good draft, but because of the way the state of Massachusetts already regulates and structures conservation easements, we have to make sure that it aligns with that. So we want to also make it something that can fit in with a traditional conservation easement, because at least out in our area, there are often upland areas of the watershed that are very important to protect from a flooding and climate resiliency standpoint. So if you couple an easement that protects upland forested areas, for example, with an easement that protects the river corridor, you're really getting a lot of extra bang for your buck.
Okay, thank you, Kimberly. How about you, Anne?
So we're still doing a lot of work with the data, and I think one of the sort of outcomes of our analysis that we hope to be able to provide to folks is some understanding of generally what kinds of places are more likely to flood based on a storm like this. So, you know, does it have to do with proximity to wetlands? How does it relate to high groundwater levels, or you know, depth to bedrock, those kinds of things, to try and really put that data together. Which still wouldn't say, is it going to flood right in this location? But I think it will be very important for folks to start thinking about, should we be expanding our wetlands regulations? Should we be expanding the areas that we review? You know, what kind of regulatory tools could we apply? Should we expand our wetland overlay or our floodplain overlay districts? I think another use that I think of is the March 2010 storm is actually, I think, very much an example of the type of storm predicted to happen more often in the future, which is big rainstorms in the winter falling before vegetation has started uptake. And in the case of March 2010, it had already been warm, so the ground was saturated because snow had already melted. And I think, based on what we're seeing, that unlike predicting where coastal flooding will occur in the future, it's really going to be difficult to model where inland flooding is going to happen for all the reasons I mentioned. And I actually think that looking backwards at signature storms like this may be more useful to towns to see where they should be thinking about than I mean, I imagine we will certainly be able to model future rivers flooding, but I think we'll have a harder time really capturing all of inland flooding. So I think this data can be useful for that.
Thank you, Anne. And Mark, you somewhat touched on this, but new project and tools that you're using.
Yeah, the products, the tools that we're developing, we talked a little bit about, but the products you can't say enough about, and sometimes I think we take them for granted. But things like LiDAR data, which are collected by, you know, usually groups like NOAA and Army Corps of Engineers and other federal agencies, they're incredibly valuable. And they become part of an integrated data set. And when you take one piece of that data set away, it affects a lot of different things. So it's really important to keep that in mind, I think. And when I talk to the public or professionals, I always tell the story recently about how, I don't know if you all have noticed how the weather forecasts haven't been as good over the past 3 or 4 months. And the big reason for that is airlines, right? NOAA and all the National Weather Service use airline data, use airplane data for upper level atmospheric readings, and they're not getting them, right? Planes aren't flying the normal routes, and that's a big part of why the weather forecast used to be 2 or 3 days out, they were pretty good, right? They get it pretty good. Now you don't know what's going to happen, right? 3 days out, it's really confusing. And a big part of that is that airline database that's not coming in anymore. And it just speaks to how, you know, we're finding out with all the shortages in weird and unexpected places, it affects science too, right? It affects the way we do our job, and affects the way we try and interpret all the data that we have luckily that we have with us. But I just wanted to sort of say a little piece for the data products that we have access to. We want to keep those, keep the interest and the need, and let people know, our representatives, that these data are really important to have coming in. I have 2 or 3 grad students who are absolutely reliant on these data sets for their thesis and for the science that they're doing. So I just wanted to say a little piece for the incoming data streams.
All right. I haven't heard any weather persons using that as an excuse yet, but the lack of, at least the sky is bluer. One general thing that, Anne, that you touched on, which has become quite a big issue, especially this week, NPR ran a couple of stories about the inadequacy of flood maps. And you touched on this. FEMA has to do a much better job of identifying these areas. And I take that from what you're saying. And if you could comment, Anne and Kimberly and Mark as well.
I think that's true, although I don't minimize what would be involved in that because I think of the complications of mapping inland flooding. But yes, I think they need to. I mean, they need to look. They need to look at smaller watersheds, those less than 1 square mile. They need to look at other sources of flooding. I actually. I don't think we're going to see that anytime soon, so I have some other thoughts about what we could be doing in the meantime. And frankly, it took, as I mentioned, nearly 2 years to get a hold of the FEMA data. And so when I had about given up on that before Joy came to my rescue, I started talking to towns about what data they had. And what I learned is that the fire departments or the 911 calls, they code those calls as water calls, and so they have data. And I actually think those of us who work directly with municipalities should really start working with towns to say, code every, DPWs and first responders need to code those calls and start mapping for themselves to understand, because storms are different too. What happens in a 2-hour downpour is different than what happened over 20 days in March 2010. There's a lot we could learn. I tend to be the modeling skeptic. Modeling is very important, and mapping is important, but I'm somebody who thinks there's a lot to be learned from actually looking at the data we have and capturing that each time.
Either of the other two panelists want to chime in, either Kimberly or Mark, on that issue?
Sure. The FEMA is currently working on a map update project that includes a lot of, or all of Franklin County, because if you remember one of the slides that I showed you in my presentation, it was of a paper map of the FEMA special flood hazard areas. And so that's what we use in Franklin County, are those paper maps. And so we are going to get digital floodplain mapping, which will be a big help, but they aren't really going to update it a whole lot. They're going to use the LiDAR data, which is good. So if you have a floodplain on the top of a hill, that'll be, corrected. And they're going to do some field work and maybe some hydraulic and hydrologic analysis. So, we in Franklin County are going to be a little bit better off in 10 years when we get the digitized version of our paper maps. But in terms of the communities I work with, I'm really, pushing or recommending, encouraging that these river corridors be mapped, and that be the management area for, in addition to the special flood hazard areas.
Okay.
Yeah, I would agree with what Kimberly and Ann have said. And the one thing I would add or amplify is that it really helps to have a bunch of different people in the room. It really helps to have conservation agents in the room, first responders, DPW, all those folks who are kind of obviously working in the same exact areas, doing different things. I think getting that information together, what Ann was saying about having, coding certain calls and things like that, it's amazing how much those little data sets build up over time and can be really, really useful.
Okay, we do have one question posted in the Q&A from David. Specific to Kimberly, what aspects of the proposed designs mentioned earlier that moved through permitting slowly do you think delayed the progress? And do you have any lessons learned during that process? And less specifically for the entire panel, what are some key regulatory and community challenges you have seen when communities are attempting to implement resiliency projects? So Kimberly, we can start with you.
Great. Well, I guess we had the kind of unusual misfortune of trying to implement these projects in these cold water fisheries resources and endangered species habitat areas. So we have these high quality resources that, again, we're trying to, bring back river functions and fix degraded habitat. And because we've got, wood turtles and long-nosed suckers and, dragonflies and other species that are regulated and protected under the Massachusetts Endangered Species Act, and then the cold water fisheries, we just had a lot of eyeballs looking at this project, and a lot of questions were asked and had to be answered. And again, because these are such new projects for the Massachusetts regulators and the structures that we have in place, we were really put under some various, very serious microscopes. So if there was a way, like for example, one of the projects that we did was a floodplain reconnection project. I mentioned that many of our rivers and streams are disconnected from their floodplains. So providing that reconnection provides a place for floodwaters and sediment and wood to be dropped out during a storm event. And so it was like less than an acre that we were trying to reconnect a portion of the South River to its old floodplain. And we also had some bank stabilization work that we wanted to do using like root wads and boulders, natural materials. But because of the fish that was present and the wood turtles, again, it just took a lot of time to permit. So and they might have to be region specific, like there might be off-the-shelf designs for the Deerfield River watershed, where if you're reconnecting a major tributary or an upland tributary, this is like the pre-approved design, and this is what you do, and these are the things that you do to protect the habitat and to restore the habitat. One component of the project that we had to drop was they were V-shaped boulder weirs to basically channel the high flows back to the center of the channel and reduce the stresses on the banks. And those, we just had to drop those after a while because we couldn't reach agreement and, kind of a good place with the regulators about the habitat improvement. So I think it's going to take time, and it's also going to take, at the state level, a recognition that this type of work has important benefits, and certainly with the Municipal Vulnerability Preparedness program that the state started 3 years ago, that program encourages what they call nature-based solutions for climate resiliency. So all these river restoration and habitat restoration projects that we've already identified are nature-based solutions. So I think, eventually the regulatory requirements are going to catch up to where the planning and the assessment work and kind of the vision that the state has for this type of work. And hopefully that happens soon. The project that is on the North River right now that's just getting finished, there's a great connecting point video that New England Public Media did of this project, and we can send the link out to folks. It took almost 5 years to get that project permitted.
And our other two panelists, some key regulatory and community challenges you have seen when attempting to implement resiliency projects. Anne?
So I think my work actually points towards my interest in more regulation. So in capturing areas that are subject to flooding and starting to regulate them, and you give me an opportunity to get a little bit on my soapbox, which would be about the building code, that in Massachusetts, communities can't supersede the building code or have different regulations. So a community can't say, we know this area floods, it should be in our floodplain, you shouldn't be able to have a basement there. That's an issue. The building code itself is statewide and could be improved if I were, if I had the magic wand. I wouldn't allow anybody to have utilities below base flood. I think basement flooding is so widespread, it's just foolish to continue to do that to folks. So that's sort of my interest is in figuring out how to use regulations really to protect people.
And Mark?
Well, just not from a permitting or regulatory perspective, just from a lot of towns, you know, we write a lot of grants with towns, right? We write a lot of resiliency grants and proposals and things like that. And it's funny, there's an incentive, or you have to have a match, right? You have to have 25% match when you're doing a project, and towns don't always have that kind of money. And it can be a disincentive for towns, especially now in the last year because of COVID. Having, you know, these projects, some of these projects are big, they're 6 figures, and coming up with that kind of money for a match, even though it's a great deal for the town, I have seen a disincentive to, they'll skip it this year, and and so work that needs to be done, that's critical really in some instances, is just not getting done because of the you know, the lack of resources to put toward, because some of these things are just cash, right? So it's a big cash outlay for these towns, and I understand that from the grantors' perspective, it's to demonstrate that the towns are engaged and involved and willing to sacrifice things like that. But in reality, I've seen it disincentivize a lot of towns to just maybe go another route. So it's a minor thing, but I think it has a major implication.
I've covered 2 questions, one about funding and one about the pandemic's influence on what's happening. Kevin has an interesting question. What do you think, this is for Anne specifically, but all of you can reply, because I think it has something to do with the lack of identification of flooding areas. What do you think is or would be the most effective way to communicate the flood risk to people who are outside the flood hazard area?
So one thought I've had that I think would be very effective would be to focus on local building departments as a key point of providing that information, because that's where everybody comes for their building permits. So I think people, when they come to a building department, they should see a map of where flooding happens outside the flood zones. They should be, you know, basically, they should be educated and harangued into doing things that are perhaps more safe than the law requires. And again, the things like utility elevate, you know, what kind of foundation should you have? I think those folks really know this stuff and are in the perfect position to get the word out. So I think that's one place. I think it should come out through emergency management. I think towns should, you know, map this data and make the maps available so that people can at least see where flooding has occurred.
Yeah, I think another troubling aspect from that NPR series was the fact that in Massachusetts is one of the states where there's no regulation apparently requiring that flood risk be disclosed to potential home buyers. And that seems to be like a really serious regulatory gap. What about that? And is any effort being made to correct that?
That's absolutely true. And I think people are looking at that from I would hope we'd see perhaps in the next session legislation about that. The other place that I think is really critical to understand that this is also in federal regulation. That's why we had such a difficult time getting access to this data, is that there are federal privacy requirements. And I think that has some implications that folks who do the kind of work that are here, that do flood management planning, this means that towns don't see the data. This means that towns who need data in order to make a case to get grants, they need to make a benefit cost analysis. There's data hidden from them that would both identify risk and potentially give them the ability to apply for grants based on damage figures. And that's hidden. So it needs to be addressed on both the federal and state level, in my opinion.
Anyone else care to comment on that? Or I had, you know, in terms of solutions or mitigating the risk of flooding, Mark, when I look at that map of Provincetown, and I'm wondering where there's nowhere to move except back into the dunes. I mean, what do you do? And there are places in Boston, like Fort Point area, where really, you know, there's very little that can be done other than lifting everything up. What are the possible solutions?
Yeah, there's a really unpleasant conversation we all have to have at some point. Over the last century, sea level has risen about a foot, right? Worst case scenario projections for 2100 is anywhere between 6 to 8 feet, right? So it's 2020. That means the rate of sea level rise over the last century is what we can expect every decade for the next, for the next 80 years. Now, it's not going to be linear, right? It's not going to go up a foot a decade, but it's going to go up fast. When it starts to go up, it'll start going fast. There's only so many options, right? This is the kind of thing where you're just sort of looking away and you're not really thinking about it. But for towns, for municipalities who have to plan 30 years out, who have to plan 60 years out, because they're going to be there, right? There might be some home front properties that aren't, but the town's going to be there. So yeah, no, it's a really big question. It needs to be addressed in a real way. And it's, there's a lot of denial going on. And there's no good answer, because there's just sometimes there's just no place to go.
And Anne, you said you can fill in a wetland, but it doesn't go away. That's a great statement. And in fact, what can be done in areas that, not quite as specific as Provincetown, but in urban areas that are really developed, aren't your options really limited?
It's a real challenge, because really we've just completely remade the hydrology of these areas, and so streams are running underneath, wetlands are buried. I think it's not a terrifically great answer, because I think some of this is just very hard to undo. I mean, there have been places that have daylighted streams, brought them back to the surface. But one thing, based on my looking at historic maps, I think that's another thing, municipalities should just look at to at least understand it, is pull out your old USGS map and see where those areas are, because they're going to line up with your flooding. And then, I don't know, Kimberly might have better ideas. I'm not the engineer or scientist when it comes to this. I'm not really certain to what degree you could start to address some of those things.
Of course, the river situation, Kimberly, I mean, we remember Hurricane Irene, the situation in Vermont, just unbelievable flooding, because the river, the water really has nowhere to go down the river. So you have unique challenges too.
Right. Oh, absolutely. And one of the projects that I'm currently involved in, it recognizes that there's only so much you can do within the river corridor and in the river itself, right? You can reconnect the river to its floodplain, you can manage the river corridor, but if you have a watershed that is just dumping unmanageable amounts of water into the river, you need to look up in those areas and see what you can do, right? So we have thousands and thousands of undersized culverts. We have, again, these tributary streams in the hills that when we get a hard rainstorm just become torrents. Like, it's unbelievable. So what are the strategies that we can use to retain the water in those upland areas and, slowly release it back into the larger tributaries? So one effective strategy that we've seen in Vermont and other places out west is what they call chop and drop. So it's literally going up into the headland or the upland headwater streams, chopping down trees, in a controlled fashion, but kind of making these water and sediment baffles, if you will, in these upland areas to slow the water down and to keep the sediment. I mean, one thing that we really struggle with out here is that the amount of sediment and wood that is mobilized when we have these heavy rain events is so destructive too, because our culverts and our bridges get clogged, and then that's just like a cascade of impacts and destruction.
Well, thank you. We've kind of reached the end of our 1 hour session here. This has been really fascinating to hear from all of you. Water everywhere. And Kimberly, what you said about looking upstream is really important, I think, for everybody. It's not that specific little area where the flooding is, but there's a lot that goes into it. I want to thank our panelists, Kimberly Noake MacPhee of the Franklin Regional Council of Governments out in Greenfield, and Herbst, Senior Environmental Planner for the Metropolitan Area Planning Council, and Mark Borrelli, Coastal Geologist at the Center for Coastal Studies in Provincetown. And I want to thank Noah Sloan for inviting me to host this fascinating session. And I'm really happy to be part of the Massachusetts Association for Floodplain Management first annual meeting. So with that, thank you to all the guests, and whatever questions have popped up, we'll try to get back to all of you with answers, even though we might not have had time to do it here during the discussion. Back to you, Noah.
Thank you, Bob, and thank you again to all of the other panelists, and thank you to all of the attendees who have been here this afternoon so far. We are going to have another short break, and our next session. Sorry, let me get my shared screen up here.